Hello JPJ Discovery Channel followers. Mars has long been known as the red planet of our solar system for its distinctive red color. Its earliest recorded name, Har-Decker, literally meant red one in Egyptian. But why exactly is Mars red? Mars' surface is dominated by a red-orange tint visible from space. The color is largely due to iron oxide, also known as rust, which makes up the dust, rocks, and soil covering the planet. But to understand how this amount of iron oxide formed, we must first understand the deep geological history of the planet. Mars, many years ago, is thought to have had a lot of water, perhaps even oceans. Mars also has a much smaller mass than Earth, which means its escape velocity is significantly lower. This makes it far easier for gas molecules like hydrogen to escape into space. With a thinner atmosphere, water vapor on the planet could rise higher, where ultraviolet light from the sun splits these water molecules. The lighter hydrogen atoms are able to escape the planet's weak gravitational pull, while the heavier oxygen atoms remain behind. Oxygen is extremely reactive, particularly with iron-rich minerals on Mars' surface, naturally leading to the formation of iron oxide. Further evidence of this process can be found in Mars' enriched deuterium to hydrogen ratio. On Earth, roughly 1 in 6,000 hydrogen atoms is deuterium. On Mars, this ratio is about 5 times higher. The oxygen was largely absorbed into the surface, forming large amounts of iron oxide. But Mars isn't just red on the surface. Images captured by Mars missions suggest that the Martian sky is also red. This reddish tint is due to the absorption of sunlight by fine dust particles and photon scattering in the near-infrared range. About 4 billion years ago, the newly formed Earth and neighboring rocky planets were hammered by intense meteor bombardment. This melted the planet's surfaces into oceans of magma. On Earth, these seas of molten rock were about 1,800 kilometers deep. Earth is almost twice the diameter of Mars and 10 times more massive, creating much more pressure at the bottom of Earth's magma ocean. On Earth, pressure raised the magma's temperature to more than 3,200 degrees Celsius, converting iron oxide into metallic iron. But on Mars, the magma ocean would not have reached more than 2,200 degrees Celsius. Iron oxide remained perfectly stable. This led to Mars losing its magnetosphere and transforming into the red desert we see today, with its distinctive color coming from iron oxide formed during its habitable era.